Hello everyone, this video is about exponential and logarithmic integration. So on MF19 you see this formula. If the f of x is e to the power of x, then the integral of f of x dx, so the integral of e to the x dx is e to the x. So exactly the same, makes sense because the derivative of e to the x is e to the x. So this is another form. If the power is not a simple x, if it's like 2x or 2x plus 3, actually we have to divide by the derivative of the power. So in differentiation, we multiply by the derivative of the power. In integration, we divide by the derivative of the power. For example, e to the power of 2x plus 3, we get exactly the same thing, but we divide by the derivative of the power, or by these two here, and we can recheck by differentiating our result here. So this is the same as 1/2 e to the power of 2x plus 3. If we differentiate, we get exactly the same thing, but we multiply by 2 because it's the derivative of 2x plus 3, and after simplify we get this, which is exactly the same as what we were trying to integrate. So this means we have the right integral. This is the right answer then. Logarithmic, we have this formula, 1 over x equals ln modulus x. So if you are interested to know why we have a modulus here, you can just watch the formula derivation video or read the PDF at least. So for this basic formula, we can also apply the chain rule. So if it's not a simple x, if it's ax plus b, then we're gonna have to divide, again we divide by the derivative of ax plus b, which is a. And we have this rule here, the last formula you can see on MF19. So this is actually just like the usual logarithmic integration, but remember the chain rule concept. So if we are looking for the integral of not just 1 over something in x, but also times f prime of x, then the integral is ln this denominator here. So this is the form in the MF19. Alright, so let's try some examples. Integral 1 over 2x plus 3, so just ln 2x plus 3 in absolute value divided by the derivative of 2x plus 3, and you can recheck by differentiating. When you differentiate, we still have 1/2, of course. 1/2 is a coefficient, so we still have it. So we get the derivative of ln is 1 over, so 1 over 2x plus 3 times the derivative of 2x plus 3. So if we simplify, we get exactly the same as the integrand. So another example is, say we have 2x minus 8 to the power of minus 1. So remember, to the power of minus 1 is the same as 1 over. So here we have ln exactly the same, 7x minus 8 divided by the derivative of 7x minus 8. And notice that we cannot use the power rule. So if you try to use the power rule, we use the 7x minus 8 exactly the same. We start with the division line, we write the 7x minus 8, the new power is minus 1 plus 1 is 0, divided by the new power 0, and also divided by the derivative of 7x minus 8. But the problem here is, if you divide something by 0, you get undefined. So when this happens, just remember you gotta use ln. So you try to use the power rule and you get undefined, that means you have to use logarithm or an ln. So here we are applying the second formula here. So if we have 3x squared minus 5x to the power of minus 1, remember this means 1 over, and here we have the exact derivative of this denominator, because the the derivative of 3x squared minus 5x is 6x minus 5. So in this case, we have ln 3x squared minus 5x. Because if you try to differentiate this, you'll get 1 over times the derivative. Now, what if we are integrating 7 over 6x squared plus x cubed times 4x plus x squared? So here, notice that the derivative of 6x squared plus x cubed is not exactly 4x plus x squared. The derivative of 6x squared plus x cubed is actually 12x plus 3x squared. So it's not like 4x plus x squared exactly, but you know, it's 1/3 of the derivative. So we can adjust the equation here by manipulating. So we multiply by 3 and then we also divide by 3, so we are not changing the value. Now we can move the 1 over 3 outside the integral because it's a coefficient. Now just expand 3 times 4x, 3 times x squared, we get 12x plus 3x squared. And as you can see, this happens to be the exact derivative of 6x squared plus x cubed. So now you can also move the 7 out of the integral here. So as you can see, this is in the form of 1 over f of x times f prime of x. And the integral is just ln this denominator here. You can check by differentiating and you'll see that you'll get exactly the same as the integrand. And last one here, another example. Tangent is sine over cos, and we can write this as 1 over cos times sine, and we can adjust this, well, now multiply by -1, also multiply by -1 again, so actually it's multiplying by 1, so we're not changing anything. The derivative of cos is minus sine, so this is again in the chain rule form, so the integral is just ln cos, but don't forget the negative, and actually we have absolute value. You can check by differentiating, you will get exactly the same as the integrand tangent x. That's it, I'll see you again next time.